How does a loose connector artificially accelerate a particle beyond the absolute speed limit of the universe? We are analyzing a multi-billion-dollar subterranean transit architecture stretching from the supercolliders at CERN in Geneva to the Gran Sasso laboratory deep beneath the Italian mountains. It is a brutalist masterpiece of modern engineering built to capture the shadows of subatomic mechanics. Yet this colossal network of unprecedented precision was fatally compromised by a mechanical oversight so trivial it defies reason. A world-class diagnostic array, effectively paralyzed by a single physical connection failing to seat flush against its receptor. The sheer scale of the false positive is what makes this silent failure deeply unsettling. Over a span of 3 unbroken years, the sensors beneath the rock logged 15,000 distinct neutrino detection events. A massive volume of discrete subatomic transit data, meticulously parsed and aggregated. The telemetry did not jitter. It did not spike randomly or degrade into corrupted noise. It was mathematically consistent. Every single run logged that identical 60-nanosecond anomaly. The state machine operated with absolute perfection, ingesting raw physical phenomena and returning clean, sequential metrics. The researchers trusted the output because the system never threw an unhandled exception. The system did not fail. It executed its monitoring logic exactly as written. But the data stream was fundamentally poisoned at the physical layer. To comprehend how a microscopic hardware flaw rewrote the foundation of modern physics, we must look away from the collision chambers. We must examine the fragile synchronization architecture that dictates exactly when things happen. To measure the velocity of a particle traveling between nodes, you do not use a stopwatch. You synchronize the departure and arrival points using an orbital reference. Satellites equipped with cesium atomic clocks beam precise temporal coordinates down to surface antennas. From there, the time signal must travel deep underground to reach the master clock board of the detection arrays. In this infrastructure, time is not an abstract integer in a database. Time is a physical packet of light transiting through a dedicated fiber optic cable connecting the external GPS receiver to the subterranean synchronization logic. The entire validity of the metric relies on the flawless integrity of this optical path. Every nanosecond is a physical distance traveled in glass. I want to ask the network engineers and infrastructure maintainers watching, what is the most catastrophic hardware anomaly you have traced back to a microscopic physical oversight? Log it in the comments below. It is a profound vulnerability of modern engineering that orbital atomic precision ultimately depends on a mechanical fastener. At 8:14:02 UTC, during standard diagnostic routines, the main fiber optic link was temporarily disconnected. When the cable was reinserted into the master clock board, the connector offered the standard tactile resistance of a closed circuit. It felt locked. It was not. The thread had caught slightly early, leaving a structural void of less than a single millimeter between the end of the glass fiber and the optical receiver. A fraction of a millimeter of dead space. The maintenance window closed. The detection state machine was brought back online. Overhead, the satellites pulsed their synchronization markers, sending photons racing down the glass conduit. Down in the dark, the incoming light reached the end of the cable and collided with a microscopic canyon of open air. A total disconnection would have triggered an immediate hard fault, halting the node and engaging the failsafes. But the void did not sever the signal. It merely bled it. As the photons crossed the unsealed gap, the optical pulse scattered. The master clock hardware requires a specific photon density to register a valid timestamp. Because the incoming light was diminished, the sensor took infinitesimally longer to build the necessary voltage and reach its activation threshold. The physical gap attenuated the light pulses, delaying the receiver's timestamp by 73 nanoseconds, which inverted the math and made the neutrinos appear to arrive earlier than they physically did. A cascading failure rarely stems from a single isolated variable. This mechanical lag compounded with a dormant hardware defect in a secondary oscillator board. Engineered to regulate timing at a strict baseline of 8.0 MHz, the component was silently drifting, operating at 8.3 MHz. The collision of these two microscopic physical flaws permanently corrupted the timing foundation of the entire node. If you analyze system postmortems and find the fragility of our digital infrastructure as compelling as I do, subscribe to the channel. We document a new architectural failure every week. The impossible physics dissolved the moment a technician finally pushed the optical connector flush against its port. By June of 2012, the research collaboration issued a formal retraction, followed by the quiet resignation of the project leadership. There was no fatal logic in the codebase, only a machine faithfully processing a poisoned stream of temporal data. A multi-billion-dollar apparatus momentarily paralyzed by a single unseated millimeter. The system did not fail. It executed its flawed telemetry exactly as wired. Next week, we examine a silent memory leak that quietly disabled a continent's aerospace tracking grid. Until then, check your logs.